multiple binary. So what does it mean? So far, we've done multiple linear regression. Dependent variable is quantitative. Independent variables are all quantitative. So we use multiple linear regression. And then we went to general linear models. So what's the difference here? So basically, the difference is earlier, all must be quantitative. Here, combination of quantity and quality. This part remains the same. Now, this also categorized qualitative two groups. So what's the difference between general linear models and logistic regression? General linear model, dependent variable is quantitative measurement. Whereas here is qualitative. This can be like blood pressure, systolic blood pressure, 120, 130, 140, and so on. But this be categorized into high and normal. You can see a sequence. So in your data, you must know what you're measuring and how you're measuring. If a dependent variable is quantitative, and these are all quantitative, then regression. If dependent variable is still quantitative, but here combination of quantity and quality, that's what in your last assignment you did, then we general linear models. Once this become qualitative, two groups called binary, two groups. This remain the same. And then we have binary logistic regression. So that's how things move from one to another. All right. Multiple logistic regression. Earlier we done SBP, job category separately, BMI separately. That's called univariate. Now I'm going to put both, then become multivariate, multiple logistic regression. Just now we did BMI alone, then we did job category. So now when put together, they become multiple logistic regression. Just observe first. So follow this instruction. Job category, SBP. Why still a mistake there? Let me check where's that. Hold on. This is BMI. Sorry, yeah. This should be BMI. All right. Okay. Same. BP category dependent. And the covariates. Oh, still a mistake. So this must be job category, yeah? So job category. JC. All right. Again, my objective is association between job category and BP. All right. So let's do this. So BP goes there, job category and BMI, because job category is qualitative. Select categorical, bring job category inside, and the 95% CI. Look at the output. Okay, look at the output. Okay, but the first one, look at the next one here. Job category, is this significant? Job category, is this significant?
No.
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 So category 1 refers to? Job category 1 refers to? We don't know yet, okay? Must check. I'm just showing that job category no more significant. Is BMI significant?
Yes.
Yes. Earlier, when I did analysis, we found that job category, there was a difference. BMI also, there was a difference. When put together, it's only BMI, not job category. And that's why I say no difference between job category, right? Okay, interactions. Interaction we did earlier last week under general linear models. So the interaction between obesity and diabetic. Obesity and diabetic. Later I'll show you how to do this. These two are qualitative, categorical. So look at diabetes, obesity, the p-value is 0.525. That means no interaction between the two. Right? So that's another one. Next. So that will be on the homework. Then I give you the assignment. Right? Okay. We're going to do this later and see how to fill out this table. So your assignment, the final presentation will be something like this. And then write up a simple write up on this. So you must know how to do this table and what to interpret. Okay, let's go to the analysis. Okay, same file. You categorize BP category into two. So now you follow the instruction. Analyze, regression, binary logistic. Just hold on, huh? Hold on. Just now I did this. SBP versus job category. It's called univariate because you need one predictor. Categorical, I define this and click OK. Just observe first. Job category, is this significant? Is this significant?
Yes.
Yes.
Yes. Right, significant, yes. So what is job one and job two? You take this table, right? Take this table and define what's one, what's two. Okay, what is one? What is job category one? One refers to attendant. Two refers to nurse. So find that one is significant, other one's not. So now we conclude, yes, job category makes a difference. Let's do BMI alone. BMI alone, we done just now. So BMI is quantitative, so no need to do categorical because quantitative. Okay? We are still doing univariate. And you find that BMI is significant. Now let's do multivariate or multiple logistic. Multiple means more than one predictor. That's all. Let's do. All of us do. Analyze. Regression. Binary logistic. Reset. Reset. Let's do all over again. Dependent variable is SBP category. Covariate, my covariate job category and BMI. Job category and BMI. Of the two, job category is qualitative. So go to categorical. Job category goes inside, not BMI. Continue. Under options, check this box, CI, confidence interval. The exponential beta is called odds ratio. Continue and click OK. So earlier we did job category alone. It was significant. And then BMI alone was also significant. Right. But combined together, categorical job category was significant, where this part is different from the other. BMI also significant. These are called univariate. Put both together, we have this particular table. Job category is no more significant. We've seen similar pattern in general linear models. So only BMI makes a difference. Doesn't matter whether you're a doctor, nurse, or attendant. If you're obese, you have hypertension, more likely. Right? Next. We want to know any interaction, meaning obese and also diabetic, does it make a difference? Being obese and diabetic, does it make even more different, right? Even more severe for hypertension. Now, don't do this first, just watch. Then you do afterwards. Let's do, okay, continue, okay? All of us do. Let's all of us do, just follow this instruction. Analyze, regression, binary. So take both out. So now we have obese and diabetes. Obese, one. And diabetes, DM, this one. Now, to get this term, the interaction term, right? To get this interaction term, you do this, right? Hold the button. So now, highlight obese and DM. Press Control, DM, and obese. Right. Press Control button on your keyboard. Highlight DM and obese, and check this box. A asterisk sign B. That's the interaction. Anyone? Question? Right. All these two are categorical. Go to categorical and tell these two categorical qualitative. Continue. So obese, DM, this asterisk sign means the interaction term. Continue. Right. So we're interested in the interaction term, this term here. That's my objective. Is the interaction between the two? Answer. The p-value is more than 0.05. Therefore, there's no interaction. Then being obese and diabetic does not make much difference. Questions? These are some more things we want to know. Again, there are much more to do with logistic regression. These are basics, right? There's no difference. Next, We're going to something similar to what your assignment going to be, how to get this table done, and how to do a write-up. Remember, always the first table must be demography, then only the results. Okay, open the file, hypertension, hypertension. Do you have the file hypertension? Class, do you have the data hypertension?
Yes, sir. We have.
Yes.
All right. Okay, what do I want to know? Okay. Whether hypertension, the first column, yes and no, yes, no. Does it depend on gender? Okay, gender, ethnicity, smoke, and then we have age, weight, and BSA, these variables. So remember, all quantitative variables, you must check for multicollinearity, same as in assignment 3, right? So step by step, first step is for these variables, check if there's multicollinearity. Let's do it. Analyze, regression, linear. I'm not doing regression. I just want to check multicollinearity between age, weight, and BSA. Right. Where's the option multicollinearity? Go to statistics and check this co-linearity diagnostics box. I can't click OK because this particular box is empty. So I can throw anything there. I can even throw this just to make it OK. That's all. So without anything here, cannot click OK. My purpose is to check multicollinearity, not regression. So dummy variable, any of them, okay, let's put there. A variable that's not inside here. Click OK. Last column. Is there a problem?
Yes.
Yes. Highest value more than 5. Which one from this culinary diagnostic? You can see the last two here. These two. They are within weight and BSA. Of course, heavier the person, bigger the body surface area. So, which one easier to measure, weight or body surface area?
Wait.
Weight. So we may omit this. You must check this. All right. Next, in the analysis, you go to form univariate analysis and do this part first. Right? So open Word file. Open your Word file. In the Word file, we have 1, 2, 3, 4. 4 columns. 1, 2, 3, 4, 5, 6. 6 rows. 4 columns and 6 rows. Okay. To start, we don't have all these values. So let's block out all these values first. Okay, prepare the table. This will be univariate, one at a time. This will be multivariate. We do univariate. I'll tell you how to proceed from here to here. Right. The title will be table Y, table X. Results from logistic regression analysis. Okay. Okay, first table, be demography, we'll have this, percentage and number, right? Your first table. Second table will be results from logistic regression. Okay, all right. So prepare the table. Okay. You're going to univariate analysis and fill up this part first. Then I show you how to proceed to multivariate. Yeah. Gender. So we do one by one first, right? So prepare the table. Right. So go to your data. Okay, hypertension data. Dependent variable, hypertension. So go to analyze, regression, binary logistic. So dependent variable, hypertension, gender first. Gender, categorical, continue, and the options, CI. Click OK. All right. So remember this table. What are you comparing? Hypertension, yes to no. Comparing yes to no. Coding. The one refers to male and there's a reference female. Okay. Right. The one refers to male. So here, gender one refers to male. Okay, what's the odds ratio here? So we'll write this. Right. So this is, so type this value here. Okay. Okay, take these values, p-value, that's a p-value, less than 0.001. Right, 8.06, and that into. Any questions?
Why is it the 4.51?
Why 4.51?
Yeah, why not 4.81?
Okay, thank you. 4.81. Thanks. So what does it say? Gender, p-value less than 0.05. Yes, hypertension depends on gender. How? The odds of a male being hypertensive is 8 times more compared to female, time being. So once you're done, continue the next one. So what's next? Next, ethnicity. So move this out. Ethnicity in. Ethnicity is categorical. Categorical. And click continue and OK. Again, who is 1, 2, 3 is very important. Right. Malay, Chinese, Indians. Okay. Hold on. The odds ratio is less than 1. Less than 1. You rather interpret odds ratios more than 1. Right? Easier to interpret the odds is how many times more. It's not easy to interpret. So when the OR less than 1, that means that group, reference group, Malay, less hypertensive compared to India. So whenever this value is less than 1, you change the reference group. You make the first one as a reference group. How to do this? We do. Go to categorical. Categorical. Click indicator. Currently indicators last, which is Indian. Change to first. First. And click change. Now the Malay becomes a reference group. Continue. And click OK. Let's see the reference group. All right. Now your one here refers to Chinese. The 2 here refers to Indian. The 1 refers to Chinese. The 2 refers to Indian. The Malay is a reference group. So we are transferring here. This will be Chinese. This will be Indian. And transfer into this. So your Malay is a reference group. Malay is a reference group, right? See Malay here, that's a reference group. So one refers to Chinese. Two refers to Indian. So this value is here, reference 4.13, this for Chinese, and that's for Indian. P value. So this overall P value, overall, this for comparison. So this is Chinese differ from Malay, and one more, Indian also differ from Malay. Right? So the first one refers to Chinese compared to Malay, significant. Second one, Indian compared to Malay, also significant. This is overall. Here only one, because only two levels. And more than two levels, overall, and comparing pairwise. Okay, Chinese, Indian, are they different? Chinese and Indian, are they different? Class?
No,
Why?
they have overlap.
Overlap. All right. We can go more detail, by time being that's enough. Okay, do the rest. Complete the rest. Smoke. Okay. Are you all done with this? Are you all done with this? Okay, look at the notes. First, perform univariate analysis. One at a time. Okay, that's univariate. One at a time. Next, test all variables in one that were significant at 0.25 level, 0.25 level. Not 0.05, okay, 0.25 level. So what does it mean? This value less than 0.25, less than 0.25, highlight that. Okay, this value also less than 0.25. That means all this qualify into multivariate. All this qualify into multivariate. Supposing this p-value is 0.785, then you won't test it here. We won't test here, right? If the p-value is 0.185, do you test or not? 0.185, do you test into multivariate? What's the threshold?
Yes.
0.25. Is it less than 0.25?
Yes.
Yes, we'll test it here. Is 0.785?
No.
No. So that's how this selection is done here. Now, do they all qualify here? The variables all qualify? The p-value is
Yes.
marked in yellow. Are they all less than 0.25?
Yeah,
All right,
all of them.
all of them. Then multivariate all go together. So analyze. Let's do one by one. What is the first variable? Okay, gender. Gender qualifies. The gender goes in. Ethnicity qualifies. Ethnicity go in. Smoke qualify. Smoke goes in. Age and weight both qualify. Age and weight. We did not take BSA because BSA and weight were highly correlated. Some are categorical, so go to categorical and tell SPSS which are categorical. So these three were categorical. Continue. The option, check this. Continue, click OK. So look at the last table. What's the gender p-value now? Is this still significant?
Yes.
Yes, okay, gender is still significant. P-value 0.027. Ethnicity, is it significant?
No.
Ethnicity?
No.
The p-value is 0.99 something. Right? If you want this, that's a reference. Oh, sorry. So that's a reference, huh? Reference. Here also can put one log. Here one refers to reference. You can put REF or one. Equal to reference. Okay. What's the value here for ethnicity? 1.0, 0.6, 1.02, 36, 2.8. All right. You can say ethnicity also is not significant. You want one more p-value? 90961. Sorry, this value should be down, huh? Right. And overall p-value is the first one. Ethnicity, that's the first one, 0.99. So it was significant here under univariate, no more under multivariate. That's advantage. That's why you must do multivariate. Smoke. Is smoke significant? Is smoke significant?
Yes,
Yes.
significant.
And smoke still significant. It's a reference. So non-smoke is a reference. P-value significant here, here also significant. Age and weight. Age and weight. So that's your age and weight. Is there a mistake? Okay, correct it, okay, accordingly. All right, that's the age and weight. So what is OR? What's AOR? Type here. OR. Or the other one. AOR. Adjusted OR. Right? What the AOR means. Adjusted from where? Based on multivariate analysis. That's from multivariate. Don't have to write this, okay? Don't have to write this for our information. Questions?
Sir, is
Yeah.
the assignment 4?
Coming soon.
Is it the assignment 4?
It will be on this, on this. Assignment 4 will be on this.
Okay,
All right.
thank you.
Okay. Let's do the write-up. What's the objective? What's the objective here? What is the study about?
To determine the factor associated with hypertension?
Yeah, correct. So there will be two objectives. Objective 1. Prevalence of hypertension. I put HTT, hypertension. Objective 2. Factors associated. Right. HPT, yeah, hypertension HPT. So what are variables? Gender, ethnicity, smoke, weight, body surface area, and age. And that's your objective. Results. So first table must be your demography. In the initial analysis or initial analysis. Right, the odds of hypertension was higher among the males. Once the males, the reference group is female. Smokers, reference group is non-smokers. So don't have to mention compared to what. Next one. All right. So actually, this is for objective number 2. You haven't answered objective number 1 yet. Okay, I show you how to get the prevalence. I've done this before. Put the data. Make sure it is hypertension is coded as 1 and 0. Hypertension is coded 1 and 0. 1 is yes, 0 is no. Okay, let's do a frequency on this. Analyze descriptive frequencies on hypertension and click OK. I can see out of the 350 respondents, 103 had hypertension. That is 29.4%. But we want the confidence interval as well. For this, an approximate value can be obtained from Explore, right? Provided hypertension is coded as 1 and 0. 1, 2 cannot. And then click OK. Right. Mean percentage 29%. That's the interval. Right? So this is the 3 figures we need. maybe one more decimal. Right. So this are figures you need to answer the first objective. Just telling 37% is not enough. Pause. 29.4% with a 95% confidence interval. This estimation equals to 24.6% to 34.2%. So in your assignment also, I expect you write this, right? By the objective, results, demography table, and explain some of the features. Discuss. Like how many percent male, how many percent female, this kind of things. Describe. And then answering the objective one. So what's the prevalence? That's done. Right? That's your objective one. Objective two. This objective two. And what's your conclusion? Are you all clear on this? Class, are you clear? Okay.
Yes, sir.
Now homework, not assignment, okay? Homework. You do this and submit now. Okay, file, dataset one. Factors associated with diabetes. Factors associated with diabetes. Okay, DM. DM is diabetes. Dependent variable, DM. Tested variable, gender, job category. Job category. Marital. Physical activity. MI. Okay. Physical activity. Stress. The stress is stress quantitative. Age. TG. All right. Make sure you check this for quantitative variables. So do this and submit now. Subject. Homework on logistic regression. The subject. Okay, are you all clear? Linda, are you clear?
Yes, I'm clear.
All right. So do this now and send before what time? Before 8 o'clock. Right before 8 o'clock. All right. Okay, that's all for today. So next week will be the last class. I'll send the notes and the data. So the assignment for this, I'll send you by Thursday.
Thursday. Okay.
Yeah, by Thursday, can be earlier, right? So you're going to do exactly the same thing like this. All right. Okay, good night.
Good night, sir.